It's 1993. A brand new heavy-duty pickup rolls off a General Motors assembly line. Under the hood sits what's supposed to be the future of American diesel trucks, a 6.5-liter turbocharged V8, built to haul, built to last, built to dominate. On paper, it looks solid. Strong torque, better efficiency, proven architecture from the older 6.2 diesel. GM had a clear goal: take what worked and make it stronger. But what almost nobody knows is this engine would quietly become one of the most controversial diesel platforms GM ever built. Because behind the torque numbers, behind the military contracts, behind the millions of miles, there was a flaw that would destroy engines without warning. And for years, GM tried to keep it quiet. You think you know this story? Not like this. Back in the early 1980s, GM was under pressure. Fuel prices had shaken the market, and American buyers wanted efficiency without giving up truck capability. The oil crisis was still fresh in everyone's mind. Gas stations had seen lines that wrapped around blocks. Prices had spiked overnight. And suddenly, the idea of a diesel pickup truck didn't sound so crazy anymore. So GM introduced the 6.2-liter Detroit diesel V8. It wasn't fast, it wasn't flashy, but it worked. It had a simple design, a cast iron block, a bore of 3.98 inches, and a stroke of 3.80 inches. That gave it 379 cubic inches of displacement. Compression ratios were sky high, around 21.31, because diesel engines rely on compression ignition instead of spark. For those who don't know, here's the difference. A gasoline engine uses a spark plug to ignite fuel. A diesel engine squeezes air so hard, so tight, that it gets hot enough to ignite fuel on contact. That's why compression matters. That's why diesel engines are built tougher, heavier, more robust. They have to be. Power? Around 130 horsepower. Torque? About 240 lb-ft. By today's standards, that sounds weak. But in the early 80s, for a light-duty diesel truck, it was enough. More importantly, it was reliable. Farmers used them. Ranchers used them. Fleet operators put thousands of hard miles on them every month, and they kept running. Sure, they were slow. Acceleration wasn't exactly thrilling, but they sipped fuel compared to big block gas engines. And in an era when fuel economy suddenly mattered, that was everything. And that's where the story begins, because GM wanted more. By the early 90s, the landscape had changed. Fuel prices had stabilized. Buyers still wanted diesels, but now they wanted power too. They wanted to tow heavier trailers. They wanted to keep up with traffic. They wanted refinement, capability, and performance all at once. Competitors were stepping up. Ford had its Navistar-built diesels. They weren't perfect either, but they were improving. And then there was Dodge. Dodge was about to unleash the Cummins 5.9L, an inline six that would completely change the game. It made serious power, serious torque, and it had a reputation for being nearly indestructible. GM needed something better, something stronger, something that could compete. But here's the problem. Designing a brand new diesel engine from scratch is expensive. It takes years. It takes testing. It takes resources GM didn't want to commit at the time. So they took the 6.2 and stretched it. The result was the 6.5-liter turbo diesel. The bore stayed almost identical at 4.06 inches, but the stroke was increased to 3.82 inches, bringing total displacement to 395 cubic inches. It still used a cast iron block, and heads, still high compression, around 21.51, but now it had a turbocharger, and that changed everything. A turbocharger is essentially an air compressor powered by exhaust gases. It forces more air into the engine. More air means you can burn more fuel. More fuel means more power. In theory, it's brilliant. In practice, it adds heat. A lot of heat. And heat would become this engine's worst enemy. Suddenly, the numbers looked competitive. Early turbo versions made around 190 horsepower and 385 lb-ft of torque. Later versions pushed closer to 215 horsepower and over 440 lb-ft. That kind of torque could tow. it could haul, it could move serious weight. For the first time, GM had a diesel that could stand toe-to-toe with the Cummins, at least on paper. And GM wasn't just selling it to truck buyers. They gave it to the military. The 6.5 turbo diesel powered the Humvee. Yes, the same vehicle used by the US military in harsh, unforgiving conditions around the world. Deserts, mountains, mud, sand, extreme heat, freezing cold. That alone gave the engine a reputation for toughness. Commercials highlighted it, salespeople mentioned it. The message was clear. If it's good enough for the military, it's good enough for your job site. But here's the thing. Military use doesn't always mean what you think it means. Military engines are often operated under strict maintenance schedules. They're serviced regularly, they're monitored closely, and when something breaks, it gets replaced immediately. That's very different from a civilian truck that's expected to run hard day after day, year after year, with nothing more than oil changes and the occasional repair. And then the real problems started. At first, everything looked fine. Trucks rolled off the line, customers bought them, fleet operators put them to work, dealerships moved inventory. The 6.5 seemed like a success. But then, failures started showing up. Not small issues, catastrophic ones. Engines overheating under load, sudden power loss, cracked blocks, coolant mixing with oil, dead trucks sitting on the side of the road, steam pouring from the hood. And the worst part? A lot of these failures had the same root cause. It started with heat. The 6.5 turbo diesel ran hot. Really hot. Hotter than the naturally aspirated 6.2 it was based on. Under heavy towing, especially in warm climates or mountainous terrain, coolant temperatures would climb fast. The cooling system struggled to keep up. Gauge needles would creep into the danger zone. Drivers would back off the throttle, pull over, let it cool down, then try again. But heat alone wasn't the real killer. It was what the heat exposed. Deep inside the engine block, there was a design limitation. The main bearing webs, the thick sections of metal that support the crankshaft, weren't strong enough for sustained high load and high heat conditions. Remember, this block was originally designed for a naturally aspirated engine, making 130 horsepower. Now it was being asked to handle a turbocharged engine making over 200 horsepower, with significantly more cylinder pressure and heat. The block just wasn't built for it. So what happened? Stress cracks, tiny at first, invisible to the naked eye, then bigger, then catastrophic, until one day, the block failed. Metal fracturing, coolant flooding into the oil pressure dropping to zero, bearings seizing, connecting rods bending, and when a diesel block fails at that level, it's game over. No warning, no second chances, just a dead engine, and a repair bill that often exceeded the value of the truck. Owners were furious, mechanics were baffled, and GM stayed quiet. And if that wasn't bad enough, there was another problem, the injection pump driver. Most people don't realize this, but the 6.5 used an electronically controlled Stanadyne DS4 injection pump. It was a step forward in technology, more precise fuel delivery, better emissions, better efficiency. To control it, GM added a small electronic module called the Pump Mounted Driver, or PMD, and they mounted it directly on the engine, right on the injection pump, right in the heat. Think about that for a second. You have a component full of sensitive electronics sitting on a diesel engine, already struggling with heat, in an engine bay with limited airflow. You can probably guess what happened next. The PMD would overheat. When it did, it would fail. And when it failed, the engine would just shut off. No warning, no limp mode, nothing. You could be doing 70 miles per hour on the highway, towing a trailer, merging onto traffic, and suddenly the truck dies. No power, no fuel, just coasting to a stop while traffic barrels toward you. Mechanics saw it all the time. One reportedly said, "It was like someone flipped a switch. Perfect 1 second, dead the next." And here's the really frustrating part. The PMD itself wasn't expensive. Replacing it was relatively simple, but diagnosing it, That was the nightmare, because the symptoms looked like a dozen other problems: bad fuel, clogged filters, failing lift pump, injection pump failure, electrical gremlins. Trucks would get towed to the dealer, mechanics would run tests, replace parts, send the customer on their way. Then it would happen again. Same failure, same sudden shutdown. So they'd replace more parts, test more systems, and all along, it was just that little module, cooking itself to death in the engine bay. At first, nobody knew why, so trucks kept coming in. Same issue, same sudden failure, and the reputation of the 6.5 started to crumble. Word spread fast. Forums started filling up with complaints. Mechanics started warning customers. Resale values began to drop. If you owned a 6.5, you knew someone who'd had a failure, or you'd had one yourself. But here's where things get interesting, because GM didn't just sit still. They tried to fix it. Cooling systems were upgraded. High-output water pumps were introduced. Dual thermostat setups improved coolant flow. Larger radiators helped manage heat better. Some models even got engine oil coolers to keep temperatures in check. And the PMD, owners and aftermarket companies found a workaround. They relocated it. Instead of mounting it on the engine, they moved it to a cooler location, often on a heatsink mounted to the inside of the bumper, sometimes even behind the grille where airflow was better. It was a simple fix: a bracket, some wiring extensions, a cooler location. And just like that, one of the biggest reliability issues was dramatically reduced. Some owners reported going from multiple PMD failures per year to none at all, just by moving it away from the heat. It should never have been necessary, but it worked. But the block problem? That was harder to fix. Some later engines had improved casting, better materials, slightly stronger main webs, revised cooling passages, but the core design never fully changed. The fundamental architecture was still the same, and under extreme conditions, the risk was still there. Meanwhile, competitors were pulling ahead. The Cummins 5.9 inline-6 was making similar torque, but with a stronger block and better durability. It used a forged steel crankshaft, massive main bearings, and a simpler mechanical injection system in early versions. It was heavier, it was louder, but it was tough. People started saying, if you want a GM truck, get the Cummins swap. That's not a good sign. Ford's Power-Stroke diesels were also evolving fast, bringing more power and better reliability with each generation. And GM, they were stuck trying to patch a design that was already showing its limits. But here's the twist. Despite all of this, the 6.5 turbo diesel didn't disappear. It kept going. Through the mid and late 90s, into the early 2000s, even beyond in some applications. Why? Because when it worked well. It was relatively simple, easier to maintain than some newer diesels. Parts were cheap, it delivered decent fuel economy, and it could still tow and haul for everyday users who weren't pushing it to the absolute limit. Plenty of owners put 200,000, even 300,000 miles on these engines, but almost all of them will tell you the same thing. You had to know its weaknesses, you had to manage heat, watch coolant temps religiously, upgrade the cooling system before it became a problem, relocate the PMD as preventative maintenance, avoid pushing it too hard for too long, especially in hot weather. Don't use it for sustained high-speed towing. Don't lug it at low RPM. Keep the air filter clean. Use quality fuel. Change the oil frequently. Treat it right, and it could last. Ignore its limits, and it could fail without warning. And that dual personality is what defines the 6.5. It wasn't a complete failure, but it wasn't the bulletproof diesel GM needed either. It existed in this strange middle ground, decent when babied, fragile when pushed. By the early 2000s, the writing was on the wall. Emissions regulations were tightening. Customers wanted more power, more reliability, more refinement. The truck market was booming, and diesel pickups were becoming status symbols as much as work tools. The 6.5 couldn't keep up, so GM made a decision. They started over. The result was the Duramax 6.6L, a completely new design, developed jointly with Isuzu, aluminum heads, high-pressure common rail injection, stronger block, better cooling, more power, Over 300 horsepower and 500 lb-ft of torque right out of the gate. It wasn't an evolution, it was a revolution. And just like that, the 6.5 became history. Production for light-duty trucks ended around 2000. Some military and industrial use continued for a few more years, but the era was over. No fanfare, no goodbye. It just faded away. And today, the 6.5 turbo diesel sits in a strange place. It's not legendary like the Cummins. It's not forgotten either. It's misunderstood. Because the truth is, this engine wasn't doomed from the start. It was pushed beyond what its original design could handle. It was asked to compete in a new era, without being fully redesigned for it. And that's where it broke. But it also proved something important. Even a flawed engine can survive, if you understand it, if you respect its limits, if you fix what the factory didn't. Thousands of these engines are still running today, still hauling, still working. Not because they're perfect, but because their owners learned. They learned what killed them, and they learned how to prevent it. In the end, the 6.5 turbo diesel wasn't just a story about failure. It was a story about compromise, about engineering under pressure, about corporate decisions that prioritized cost over capability, and about what happens when an engine is caught between two generations. It was the bridge between GM's old-school diesels and the modern Duramax era. It had to carry that weight, and it cracked under the pressure. A simple block, a turbocharger, and one small electronic module, mounted in the worst possible place. That's all it took to turn a promising diesel into one of GM's most debated engines. Some call it a failure, some call it underrated. The truth? It's both. If you enjoyed this deep dive, let me know what you want to see next. Another controversial engine, a legendary rivalry, or a hidden piece of automotive history. And if you want more stories like this, make sure you subscribe.